Welcome to The Explainer. Today, we're decoding a truly fascinating cosmic mystery, one that directly impacts our search for extraterrestrial life. We're talking about giant alien worlds, massive oceans of molten rock, and these incredible invisible shields that might actually make life possible in the darkest, most distant corners of our galaxy. It really all starts with that ultimate question, right? Can we find life elsewhere? It's something that has absolutely captivated humanity for generations. But to even begin to answer it, we've got to understand what makes a planet habitable in the first place. So today, we are going to look at some incredible recent research from the journal Nature Astronomy that completely shifts our understanding of where life might actually be hiding. Section 1. Super-Earths Unveiled, the most common planets in our galaxy. Okay, let's dive into this. A super-Earth is exactly what it sounds like, but, well, with a massive twist. These are rocky exoplanets that are much more massive than our own planet, but crucially, they don't have those thick, suffocating gaseous envelopes like giant planets such as Neptune. What makes them truly mysterious to astrophysicists is their sheer abundance. They're actually the most widespread, literally the most common category of exoplanet in our entire galaxy. Yet, strangely enough, they are completely absent from our own solar system. Just let the scale of that unknown sink in for a second. The absolute most common type of world out there in the dark is one we've never been able to study up close in our own cosmic backyard. Section 2. The Earth's Shield. How our planet protects us. Now, before we can understand how these giant alien worlds might harbor life, let's look closer to home. Picture what's happening deep inside our own planet, keeping us safe every single day. We have an invisible shield, and it's produced by convection movements deep within, specifically in the liquid iron outer core. As that super hot molten iron churns and flows, it generates a massive electrical current, which in turn creates the magnetic field wrapping around the globe. In physics, we call this a dynamo. Without this life-saving dynamo, our atmosphere would be quickly stripped away by harmful cosmic radiation. It's really the ultimate prerequisite for life as we know it. Section 3. The core problem, a challenge for super-Earths. Let's contrast these two planetary models. First, we have the Earth model, a liquid iron core happily driving that convective dynamo. But then consider the super-Earths. Because of their immense mass, their internal pressures are completely different. Their cores might be entirely solid, or they simply might lack the specific internal state needed to power a traditional dynamo. So researchers faced a terrifying astrophysical problem. These incredibly common super-Earths might be completely deprived of magnetic protection. And, well, no shield usually means absolutely no chance for life. Section 4. A magma ocean, an unexpected solution. Just as scientists thought these massive worlds might be barren, irradiated wastelands, a sudden breakthrough emerged. Here is the incredible plot twist from researchers at the University of Rochester, published in Nature Astronomy. They propose the existence of something called a basal magma ocean. We are talking about a deep, immense layer of molten rock sitting right at the base of the planet's mantle. Instead of relying on a liquid iron core like Earth does, this massive, churning ocean of liquid rock could actually act as a planetary generator. And fun fact, Earth itself likely had its own massive magma ocean billions of years ago, before it cooled into the planet we know today. So how exactly does a rock ocean turn into a giant magnet? Well, the research team proved the physics using highly advanced laser shock experiments combined with computer simulations. Here's how it works. Step 1 is extreme pressure. Deep inside a super-Earth, the pressures are absolutely unfathomable. Step 2, under these intense extreme conditions, the molten rock fundamentally changes its properties and becomes highly electrically conductive. Finally, step 3, as this newly conductive magma ocean churns over time, it generates a durable, powerful magnetic field. They actually recreated these high-pressure alien conditions in a lab to prove this operates according to the strict laws of physics. How wild is that? Section 5. The hope for life, more powerful cosmic shields. So, the crucial point is, what does a magma ocean actually mean for the big picture of our universe? The implications for habitability are absolutely massive. A magma-generated shield offers that vital protection from deadly cosmic rays. But it gets better. According to the scientific models, these magnetic fields could potentially be even stronger and more persistent than our own shield here on Earth. This incredible defense system leads directly to the creation of highly stable surface environments. By having this robust protection against radiation, super-Earths with basal magma oceans significantly increase the chances of finding favorable conditions for life elsewhere in the universe. It's an elegant, beautiful solution provided by nature itself. Which leaves us with this final, thrilling thought to ponder. If the galaxy's most common planets have their own built-in cosmic shields, who else might live there? This paradigm shift completely redefines where we should be pointing our telescopes. It turns what we thought were dead, rocky giants into potentially the most vibrant, protected sanctuaries in the entire cosmos. Thank you so much for joining me on this explainer. Keep wondering, keep looking up, and I'll see you for our next deep dive.